So our next speaker, Tom Raimondo, is a professor of geology and geochemistry at the University of South Australia. And he is basically mainly sort of interested in how mountains form in the center of tectonic plates and how fluids control the strength of rocks. But Tom is also a very passionate science communicator, and he leads the project LIFE, which involves the application of virtual environments and digital visualization technologies in education and geoscience. So looking very much forward to this talk. Welcome, Tom.
All right, thanks, Mario, for that introduction, and to the organisers for the opportunity to speak today. So the emphasis of today's talk will be the exploration metaverse. Now, if you don't know what that means, don't worry, we'll get into a little bit of the terminology and the way it's applied in this context. Now, the work I'll be presenting today is absolutely not my own. Jack Fraser, Andrew Cunningham and Bruce Thomas are really key players in this in terms of the different VR and AR platforms that I'm going to introduce. We are all part of the Australian Research Centre for Interactive and Virtual Environments at UniSA, as you can see there. So, firstly, what I'll do is start with an explanation of the exploration metaverse and how it's applied in the various different examples that I'm going to present to you today. I'm going to focus on LogAR, which is this augmented reality core logging platform. There are a couple of others that I'll mention briefly now. So this is the primary focus, I guess, using augmented reality to enhance the core logging process. I'll be stepping you through exactly how we do that and what the benefits are. But we also have a few other projects that we've done in parallel to that. One with OzMinerals, which is using VR to visualise spatial datasets and exploration datasets, geophysics, inversions, borehole data, and so on and so forth in a VR environment. And in particular, incorporating a collaborative aspect so that multiple users can inhabit the same VR scene and collaboratively analyse and interpret data in VR. And the final one is a thing we call immersive analytics, which is using a VR environment again to interrogate data by using natural gestures. So rather than using a keyboard and mouse or a desktop environment that we're familiar with, rather using your hands and using the full 360 degrees of workspace around you to get new insights into your data, in this case a bunch of geochemistry. So, if this is going to advance, maybe, there we go. So, the exploration metaverse. I don't need to reiterate this too much, I don't think. We are not for want of data in the geosciences, okay? We have incredibly high quality data and a lot of it that we need to deal with. What we lack are the tools to better analyse it, to better understand it. That's where the projects that I've just introduced to you come in, okay? We're trying to work beyond the limitations of the tools that we've got at the moment. We're trying to analyse our data more efficiently. VR and AR offer us one way to do that, which I think is highly effective. The main reason for that is it gives you what we call space to think. So rather than being constrained to a desktop environment, rather than being constrained to the traditional input methods we use, we rather have 360 degrees of workspace to work in, which means we can apply a very modular approach. We can have one type of data in front of us in here. We can have a completely different three-dimensional visualisation of the same data set or complementary data sets wherever you like in 360 degrees of space. So you do engage your brain differently, you do think about things differently, and hopefully that leads to better insights and a more efficient way of interacting with that data. So we're all, in many ways, the geological surveys in particular, working towards data convergence, better interoperability and so on. VR and AR are the tools to do something with that once we've achieved that interoperability. So let's talk about LogAR, which is this augmented reality core logging platform. What I want to start with is this image, which really I think encapsulates the opportunity in a nutshell. These two images were taken on the same day down at Tonsley in the core library. On the left-hand side, we have an exaggerated example, yes, of the traditional approach to core logging. This was actually done by, I won't name names, but he is in the room. Literally post-it notes placed on the drill core, something that could float away in the breeze. A bunch of observations or interpretations that amount to not much more than that. Entirely done by a single user, entirely analogue, and so on and so forth. On the right-hand side, though, we have a demonstration of the augmented reality system. We have multiple users, some using iPads, some using HoloLenses, and it's, what I would say, data-driven. We are bringing in data into the core logging process, information that's derived from things like HighLogger and analyse and so on and so forth. All of these really rich data sets that actually allow us to calibrate our observations and interpretations. That's what we're working towards with LogAR. So, where did this come from? It's through the MinEx CRC Opportunity Fund. We have developed this through that, through that scheme. You can see the goals of the project there. I won't reiterate them for you, but essentially we're about 12 months into this project. We have a working prototype, which I'll illustrate for you now, and show you all the various functions, I suppose, and efficiency gains, I think, that it achieves. So I'll play a video now, which will kind of show you it in action. That's much better than me trying to verbally describe it. If you want to, there is a YouTube link as well there where you can see this for yourself at any time. Okay, so the basics of the platform. It works in two different modes, either with an iPad, which is very approachable, very familiar to us, where you can simply use a touch interface to bring up many of the visualizations, or the alternative is using a HoloLens, which is an augmented reality set of goggles, transparent, so you can see the world around you, but there are graphics superimposed on that, which are the data streams that are informing you. There is also a fully virtual version. So this is using HighLogger imagery. It has a very similar interface. There is no need to access the physical core samples when you're using this system. It means you can access them from anywhere across the globe. A great way to open up our borehole repositories to people from other states and internationally. Now there's a network mode as well, so you don't need to use them entirely independently. You can use the benefits of both the HoloLens and an iPad, for example, to sync, trigger visualizations and have the two systems talk to each other. All the data is fed live from the National Virtual Core Library. There is the South Australian and the WA geoservers in there at the moment, so you don't need to have any information whatsoever preloaded. You can pull that live from the National Virtual Core Library, which has all of the mineralogy from HighLogger. In many cases, it has continuous downhole geochemistry from analyse and so on and so forth. You select the data you want, and then it's superimposed on the core in front of you. And you can see a bunch of legend information that will explain what you're looking at and provide contextual details and so on. And you can have multiple attributes enabled simultaneously, as you can see there. You can extend the visualizations out further than the core trays allow and so on, if you really want to get an entire whole analysis of what you're doing. And as you can see here on the HoloLens version, we also provide summary plots. So an integrated view from the top to the bottom of the hole that you could zoom into and zoom out of, depending on the level of detail that you want to view. The visualizations are designed to work with you as well, so they shrink as you advance closer to the core to get out of the way. And you can also, there's a bunch of different functionalities where you can tweak them according to what you want to focus on. You can focus on a specific interval of values, if that's what you're most keen on. You can stretch the vertical exaggeration of them. So a bunch of customizations. You can add different color ramps if you prefer. There are also a bunch of other tools which I think are going to come up now, which I can show to you. So you can get a depth estimate, a really simple example, but there's no need for a tape measure anymore, which some of you might be relieved about. There's this X-ray vision, essentially, where you could place it showing a downhole data set here, but equally it could be image-based data set, so something hyperspectral imagery from CoreScan, for example, or whatever else. That you hover over the tray, and it's almost like having X-ray vision to see what's underneath. You can add spatial markers, so points of interest, for example, a sampling location, a structural measurement, whatever it might be. And you can create a digital log, so splitting the core, creating intervals, creating domains, adding metadata to them, adjusting them according to the precise positioning on the core that you want to visualise, and it's an entirely digital workflow that preserves all that information. The holes themselves are also displayed in 3 dimensions, as you can see there, with a geophysics layer, for example, or the ortho imagery draped over the positioning of the boreholes themselves to give you all of that contextual information that actually really assists you in the core logging process. So that's LogAI in a nutshell. I want to talk about this, data-driven core logging, right? So this is a fully digital workflow. The massive advantage of that is if you think about all the pairs of eyes that look at a segment of core these days, what happens? Most people take notes in a notebook, they might put it in a laptop. You know, they each might have their different ways of doing it. All of that information, in most cases, is entirely lost. Okay, it's not archived appropriately. You have no idea what other interpretations or measurements or intervals have been placed on there by previous users. When you have a digital workflow, all of that can be lodged and archived. So when you go and visit a core for the first time, you will see, you'll get the full benefit of every other person that's ever looked at that segment of core. The other thing is that you are using data to inform the decision-making process. Everything that's in the National Virtual Core Library, yes, but there's any data you might like. Any downhole information can be superimposed, can be visualised in some way. Okay, we are pulling data live, as you can see there from the geoservers, but there are a number of other ways that we could bring data into the equation. The other one, the final dot point there, I think is really exciting. Bringing machine learning into the equation. I think this is a game changer in terms of speeding up the logging process. We can run the downhole geochemistry and downhole mineralogy, for example, through a multi-scale logging algorithm, which will predict what we need to do. So rather than us monotonously walking up and down long segments of core, we can do all of that in advance. We can use the geochemistry and the mineralogy to predict what the interval should be using a tool like Data Mosaic. We then go in, visualise that using the AI tools that I've just introduced, and we get geologists doing what they do best, which is looking at detail. So superimposing the predictions on top of the core itself and just ground truthing that. Now, in terms of getting access to high quality pre-competitive data, I think this is the way to go, right? This is really what services like the National Virtual Core Library, that's what they exist for, right? Don't bury that in a web service, put it in front of you, superimposed on the core itself, and allow that to make better decisions, better insights into the core. So just to give you an idea about this machine learning possibility, what you can see in the graph there is on the very left-hand side, the compositional variables, so the downhole geochemistry. In this case, I think it is, you can see, yes, on the far right, iron, potassium, calcium, titanium, and niobium. So they've all been run through the system, and it's made a bunch of predictions. So it's produced a pseudo-log of what the core should be. Now, there are different domains. You can lump or split it according to what level of detail you want. On the far left of the scale, you can see there is when you have really fine scale variations, and on the far right is when you're only interested in the very broad detail. Okay. Now, what does that look like when you throw it into log AR? This is the developer view because it's a bit easier for me to illustrate what I'm pointing here. So we load that multivariate analysis into log AR, and then we vary the domain scale. So keep your eye on just this bottom plot here. The ones above that are the downhole geochem that this information is derived from. And in this case, I'm varying the domain scale according to the level of detail I want, whether coarse intervals or very fine intervals, okay? So varying that up and down. Once I've settled on one that I like, then I can start to visualise that. So this is what the visualisation space would look like. As I vary that domain scale, the visualisation updates, and then I simply go in at a very coarse scale or a very fine scale and verify where the machine learning algorithm has predicted a domain exists. That's the ground truthing aspect, if you like. Now, the really neat thing, I guess, once you've done that, is you can convert that into a user log. So pick the interval that you like, pick the domain scale that you like, and then what you'll see in a second, I'm going to settle on something here, I think, and say that, yes, I like it. And then what's going to happen is I'll select convert to a user log. I'll convert it in a second, as you'll see there. Convert that. And now what I have, essentially, once I update the visualization, is an editable digital core log. So now we have a bunch of intervals that the machine learning algorithm has predicted. If I don't like them, I go in and I adjust them. That's my expert interpretation cast over the top of it. I can edit all of the descriptive information and categorical information that's provided on top of that. This follows the GSWA schema, but it could follow any schema you like. You can enter text, enter labels, enter measurements, enter comments, whatever you like. All of that is preserved in a digital workflow. That's fundamentally starting with the machine learning process, but then refined by user input. We can get to that in the question time if you like. That's where we're at in terms of the system itself. We are incorporating new features and so on. There are different contexts in which this tool might be applied that we need to develop different tool sets for example. We want to incorporate image-based data sets, like I said, like hyperspectral imagery, for example, or photomicrographs could be another example. There is a range of different development opportunities, I suppose. That should be updated actually. We're about 12 months in at the moment. We are looking towards commercialisation of the platform. We are interested in people that want to test the platform at scale, I guess. We would love that sort of feedback and the way that it could be applied in your particular context. So please do get in touch if that's the case. And the other thing I should point out is you can try it for yourself. So we've got it on display out in the exhibition space so you can see out there. You'll be able to see the tool, try it in action. So please do come and visit. if that's the case, or shoot me an email if you don't have a chance to do that. I'm more than happy to explain more about the process. Now, that's not all though. So we not only have the log-AR system, we have a full digital twin of the Rocksplorer drill rig. If you'd like to, this is the full CAD model of the Explorer, the Rocksplorer itself. You can view that in VR if you'd like to. So if core logging is not your thing, then maybe this is a bit of eye candy. You can simply just check that out. We will be using this through the Minex CRC for training, essentially training new drillers on the operation of the platform to get them familiar with it before they actually deal with the physical drill rig itself. Okay, so you can try that out in VR if you like. And if even that's not exciting enough, then I guess we have the other option on the plate, which is we are launching today 360 Flinders Ranges, which is an immersive virtual tour for the Flinders. So if you don't care about drilling or core logging at all, and that's not your thing, just have a bit of, the spectacular natural landscape of the Flinders, if you like. We've created this virtual tour in support of the World Heritage nomination. It's a way for people to access the incredible scientific value, the incredible cultural and heritage values of the Flinders Ranges. You can swim with the Ediacarans, basically, as you can see there. You can head underneath the water 600 million years ago and see what that natural environment would have looked like, where these earliest life forms on Earth would have existed. You can swim with them and learn all about them. You can float above Wilpena Pound, a 3D render of that. You can learn about the mining and exploration history of the Flinders Ranges as well. So the Blinman mine, Sliding Rock, all the earliest copper discoveries and developments that we had through there that led to where we are today, essentially. And a cast of interesting characters and so on to see as well. So if you are interested, the website is 360 Flinders Ranges at Project Live, as you can see there. Please do come and check it out. It's also available out there in the exhibition space if you want to give it a try. So please come along, say hi, see what you think. Thanks for listening.